Alright, so questions 1 through 4 are pretty familiar. We saw them on the last review, saw them on the last quiz. So it just says state if each sequence is arithmetic, geometric, or neither. So arithmetic is when we add to get from one number to the next. So we add a constant number. Geometric is when we multiply a constant number. And if we're not doing either of those, like we're just adding different numbers each time or multiplying different numbers each time, then it would be neither. So it has to be the same number. So here we can see we're adding 3 to get from -2 to 1. And then from 1 to 6, we're adding 5. So since these are not the same, and we're not multiplying by a constant number either, this would be neither. Number 3. What are we adding to get from 13 to 23? And we're adding 10 to get from 23 to 33. And 10 from 33 to 43. So since we're adding the same number each time, adding means it's arithmetic. So number 3 is arithmetic. Alright, next let's take a look at number 5. So we have to find the common difference, the rule, and the given term for the arithmetic sequence. So it tells us that it's arithmetic. That means we're adding to get from one number to the next. So here we can see we're adding 9. And then we're adding 9 and adding 9. So what's our common difference? 9. Our rule is we just plug in our first term and our common difference into the formula. So that's a sub n is equal to, we start off with a, our first term, so that would be 36, plus n minus 1 times d, which we said our common difference was 9. So this is our rule. In your rule, you don't plug in anything for n yet. Our rule just says we can plug in any number for n that we want to find that term. So we keep n just as n. And then next we find our term. So we're going to plug in 21. So we have a sub 21 is equal to 36 plus 21 minus 1 times 9. So 21 minus 1 is 20. So 36 plus 20 times 9. 20 times 9 would be 180. And 180 plus 36 is 216. So a sub 21 is 216. So our answers here would be D for our common difference, our rule, and our term. Any questions here? Alright, next one. Doing the same thing. So here we can see we're adding 5 to get from one term to the next. So our common difference would be 5. For our rule, we plug in our first term and 5. So we have a sub n is equal to negative 25 plus n minus 1 times negative 25. And then to find our term, we plug in whatever term it tells us. So here we're plugging in 30 for a. So a sub 30 is equal to negative 25 plus 30 minus 1 times negative 20. Nope, times 5 is our d. So this should be 5. So 30 minus 1 would be 29. 29 times 5 is 145. And then 145 minus 25 is 120. So our answers here, we have our common difference, our rule, and our term. Any questions here? All right, let's go to the next page. So we're doing the same thing here, but with the common ratio. So for common ratio, in a geometric sequence, we multiply to get from one term to the next. So here we can see we're multiplying by 3. So our ratio is 3. Our rule is a sub n is equal to, we have a different formula when it's geometric. So this is our first term, 4, times our common ratio, which is 3, to the power of n minus 1. We can just leave it like this. There's our rule. And then next, we have our term. We're looking for a sub 9. So we're plugging in 9 for n. So we have 4 times 3 to the power of 9 minus 1. 9 minus 1 is 8. So 3 to the power of 8 is 6,561. And then we just multiply this times 4. So that gives us 26,244. So that's our term, this is our rule, and this is our common ratio. Our 3 answers there. Any questions on that one?
Wait, can you go back?
Yep. All right, 11. So here we can see that we're multiplying by negative 2. So our common ratio is negative 2. Our a sub n, so our rule is a sub n is equal to our first term, which is 2, times our common ratio, which is negative 2, to the power of n minus 1. And then next we have to find our term. So that would be a sub 11 is what we need to plug in. So 2 times negative 2 to the power of 11 minus 1. So just remember, you got to follow your order of operations. We have 11 minus 1, which is 10. So negative 2 to the power of 10 would be 1,024. So we have 2 times 1,024, which would be 2,048. That's our 11th term. So our answers here, we have our common ratio, our rule, and our term. All right, number 13, our word problem. When you were 3, you had 8 action figures, and every year after you added 3 more action figures to your collection. How many action figures did you have in your collection when you were 9 years old? So when we were 3 is when we started. We had 8 action figures in our collection. Every year we added 3 more action figures. So this would be plus 3, would be 8 plus 3 is 11. Then plus 3 would be 14. So this is when we were 3 years old, 4 years old, 5, 6, 7, 8, 9 is how far we need to go. So we just keep adding 3 until we get there. So when we were 6 years old, we had 17. When we were 7 years old, we had 20. When we were 8 years old, we had 23. And 9 years old, we had 26. Any questions here? All right, That was the last one on that page. Let's go to the next page. So now we have our circles. This is kind of our newer stuff. This is section 10.3. It says use the information provided to write the standard form of the equation of each circle. So our standard form of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where h and k is our center and r is our radius. So we need to figure out what our center of the circle is and plug that into our formula. So our center is right there. What is this point for our center? So remember, the x-axis comes first, so we move, perfect, -4, -1. So we have x, if we have minus a negative number, what does that turn into? A plus. So x plus 4 squared plus y. Again, we have minus -1, so this would be y plus 1 squared. And then it's equal to, now we have to figure out what our radius is. So we count how many spaces from the center to the edge of the circle. So our center is at -4, and the end of the circle is at -3. So that would be 1 space. So what is 1 squared? 1. So our radius squared is 1. That's our equation of our circle. Let's look at 16. So we have our center that's here. What's the coordinate point of our center? -2, -1. So we plug that in. We have x minus -2, so it becomes plus 2 squared, plus y minus a -1, so it would be y plus 1 squared, and that's equal to our radius squared. What's our radius here? How many spaces from the center to the edge of the circle? 2. We have 1, 2. So our radius is 2. What's our radius squared? 4. So remember, in your equation, it's always the radius squared. So that would be 4 here. Any questions on these types? All right. Number 18, we're doing the same thing, but in the opposite way. We have to identify the center and the radius from the equation that's given, and then graph it. So what's our center here? Awesome. 3, 2. Remember, we have to take these and we flip the signs. So 3, 2. So we're going to go to the right 3 and up 2. There's our center. What's our radius? Perfect. So our radius squared is equal to 9, which means our radius is 3, because we would just take the square root of 9. So we're going to go 3 to the left, to the right, up, and down. So we're going to count 1, 2, 3. To the right, 3 down, 1, 2, 3. Put us here. 3 to the left, and 3 up. Once we have our dots, we just connect them with the circle. Any questions? Alright, 20. What's our center of the circle? -4, -1. Perfect. We take these and just flip the signs. So we're going to go to the left to -4 and down to -1. That's our center. Now what's our radius? 1. Our radius squared is equal to 1, and if we take the square root of 1, that means our radius is 1. So we're going to go to the right one, up 1, left 1, down 1, and then we just connect our dots. Any questions? Alright, 22. These are factorials. So for factorials, when you have 5 with that little exclamation point, that means you multiply that number times every number that comes before it. So this is 5 times 4 times 3 times 2 times 1. When you see a factorial question on the test tomorrow, I need to see your work. You cannot just write the number. So I need to see your work. Even if you just put this into the calculator, I still want to see this written out. So you're not going to get credit if you don't show your work. So let's put it into our calculator now. We have 5 times 4 times 3 times 2 times 1, and that gives us 120. Any questions here? Alright, let's do 24. So we have 9 factorial on the top. So this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on the bottom we have 7 factorial, so this is 7 times 6 times 5 times 4 times 3 times 2 times 1, and 2 factorial, which is 2 times 1. Now we could put all of this into our calculator, multiply it all together. You'll get really big numbers and easy to make a mistake. If you see anything that repeats on the top and on the bottom, it helps just to cancel it out. That way you don't have to put it in your calculator and worry about multiplying all of these together. So we can cancel out the 7s, the 6s, the 5s, the 4s, the 3s, 2s, and 1s. So then on the top, we're just left with 9 times 8. What's 9 times 8? 72. And on the bottom we have 2 times 1, which is 2. And 72 divided by 2 is 36. So 36 is our answer.